Welcome to Olympiad Primer. Today I would give you a problem on factorial function. I think many of you have already learned what factorial function is. It is very easy. Factorial function of a number is a consecutive multiplication of a number from 1 to that number. So it's not a problem. I have also discussed the factorial function from the very beginning of the solution. But one thing I would tell you what you should remember, that actually while seeing the solution, you have to find out the main attacking point of the problem, right? The main attacking point. Yes, the main attacking point is it may be a mathematical manipulation or an expression or a step, but after that step in your mind, it will be very much easy to complete the solution. So, and apart from this step, apart from this idea or expression, what is I call it the main attacking point. After clarification of this attacking point of the problem, which has well link to the problem as well as the solution. After this attacking point, the whole solution is very much appears to be very much easy. So I think you have well understood what is the main attacking point. So mere solution of a few problem is not actually the desirable for any learner students. You should learn to store the many such attacking point of many problem, and such if you have already learned some tricks, some attacking point of problem, then one such trick can you can apply it, then your ability to solve many new type of problems would be increased, and you will be a good problem solver. So there is no shortcut. Only solving problem would increase your ability to solve problem. So let us come to the problem first. And one thing, other than this attacking point, the whole solution is nothing but clarification, explanation, and mathematical calculation, etc. So you should focus the main attacking point of the solution. Also, you should see the full solution, and you should remember it, but your focus will be on the main attacking point. So let us come to the problem. The problem is, how do you prove that factorial n square is greater than n to the power m? The problem is very easy, and you will know a mathematical trick is used, which is very important. Now see, at first we know what does factorial n means. We know 1 factorial is 1, 2 factorial is 1 into 2, 3 factorial is 1 into 2 into 3, 4 factorial is 1 into 2 into 3 into 4, and in this way n factorial is 1 into 2 into 3 into 4 dot up to into n. Now see, factorial n square, what will be its expanded expression? We know it, 1 into 2 into 3 into n minus 2 into n minus 1 into n whole square. It's the increasing order. Now we can write so whole square means 2 times, so 1 into 2 into 3 into up to n minus 2 n minus 1 then n and then cross into, because here are square, so we can write the same, because another expansion of factorial n. So this is the expanded expression of factorial n square. And now n to the power n means n into n into n into up to n times multiplied n. Clear? So it's okay. These are n times. Now see, here we may compare the factorial n square and n to the power n for some small values of n. Suppose for n equal to 2, then factorial n square, like factorial 2 square, that is 1 into 2 whole square, that is 2 square, that is 4, and 2 to the power 2 equal to 4. For n to the power n, here 2 to the power 2, that is 4. And for n equal to 3, factorial 3 square, and factorial 3 square means 1 into 2 into 3 the whole square, and here 1 into 2 into 3 means 6 square, that means 36. And here for n equal to 3, n to the power n would be 3 to the power 3, and 3 into 3 into 3, that is equal to 27. And for n equal to 4, factorial 4 square means 1 into 2 into 3 into 4 whole square, that means 24 square, that means 576. And for n equal to 4, n to the power n would be 4 to the power 4, that is 4 into 4 into 4 into 4, that is 256. So now we have shown and compare the factorial n square with n to the power n for taking some values of n, and we saw if n equal to 2, then factorial n square and n to the power n, that is factorial 2 square and 2 square, that is 4 and 4 are equal. So but for n equal to 3 and n equal to 4, always factorial n square is greater than factorial factorial n square is greater than n to the power n. Now see, let us start to prove factorial n square would be greater than n to the power n. How can we prove this statement? Here factorial n square, we can write the expanded expression of factorial n first from increasing order, 1 into 2 into 3 into n minus 2 into n minus 1 into n, then in decreasing order in the second line, n into n minus 1 into n minus 2 into 3 into 2 into 1, and then we can just use we can make the couple, taking one number from the first line and with the second with the corresponding number of the second line, that is in this way 1 into n and 2 into n minus 1 and 3 into n minus 2, and then dot n minus 2 into 3, the n minus 1 into 2, then n into 1. So these are the 2 times multiplied values of factorial n, that is factorial n square. So just we see this, and this would be in use, and this is the couples are n couples. So this is clear. Now see, suppose a mathematical trick is used here, and this mathematical trick would be from your own mind. K, you have to take k is any positive integer and is less than or equal to n. That is, k can take any value from 1, 2, 3 t up to n, but not greater than n. So we can write n minus k equal to n minus k, and this is equal, both sides are equal, both side is equal, and if we multiply k in the left hand side, that would be greater. So k into n minus k clearly greater than n minus k, because we multiply k in a side, so that side, that is left side, would be greater. Now then just we have added k of both sides, and then just we in the right side, plus k minus k will be vanished, and left side we can take common k. So k into n minus k plus 1 is greater than n, and if we take k and 1 is one single set, then we can write k into n minus k minus 1, because the sign of k is negative. So if we take k and 1 is one set, then it would be k minus 1. So here look at this couple, that is k into n minus k minus 1. It is very important couple, k into n minus k minus 1 greater than n, because see, do you have any similarity of this k into n minus k minus 1 with the couple of like 1 into n, 2 into n minus 1? So in this way, here we have written in green colored line the expanded expression of factorial n square. Here are n couples, and you see the every couple of the expanded expression of 2 times multiplied factorial n, that is factorial n square. So every couple can be expressed in the form of k into n minus k minus 1, and you see here are n couples. So for n couples, that would be n time multiplied, that would be greater than n time multiplied n. So we have clearly we may clearly understand, and we may write factorial n square is greater than n times multiplied by n, because every couple is greater than n, because every couple can be expressed in the form of k into n minus k minus 1, and which is greater than n. So every couple is greater than n. So n times couple, for n times couple, that would be greater than n to the power n, n times multiplied n, that is n to the power n. So I think every one of you have understood it. Now for more clearly we may understand it, we may clarify in this way. The couple k into n minus k minus 1 is greater than n. We have shown it, but now we can take the values of k from 1 to n. Like first put k equal to 1, then we get 1 into n, because when we put k equal to 1, then 1 minus 1 would be 0. So n minus k minus 1 would be n. So here k into n minus k minus 1 would be 1 into n, that is greater than n. And now put k equal to 2, then we get 2 into n minus 1 greater than n. And then put k equal to 3, we get 3 into n minus 2 greater than n. And so in this way, if we put the value of k in increasing order, then one time will come when we can write k equal to n minus 1. For k equal to n minus 1, we may write n minus 1 into 2 greater than n. Here look at this, the value of k is n minus 1. So the value of k into n minus k minus 1 would be, for k we write n minus 1, and the value of n minus k minus 1 would be n minus 1 minus n plus 1. So the value of the n will be vanished, and 1 plus 1 would be 2. So we have written n minus 1 into 2. And then for k equal to n, we may write n into, clearly n into n minus 1, that is n into 1, and that is greater than n. So if we multiply all the n equations, that is from top to bottom and from left side, we get 1 into 2 into 3 into n minus 1 into n, and then the right sided factor, that is n into n minus 1 into n minus 2 into 2 into 1. So all are multiplied, and two sets. First line you see 1 into 2 into 3 into n minus 1 into n, and the second line n into n minus 1 into n minus 2 into 2 into 1. The first line is increasing order of the expanded expression of the factorial n, and second line is the decreasing order of the values of the expanded expression of the factorial n. So here clearly factorial n into factorial n is written, isn't it? So equal to factorial n square, and see the right side, when we multiply the right side of the n equations, that is clearly here n times multiplied by n. So n into n into n into here n times multiplication of n, that would clearly n to the power n, and all are greater than. So greater than, left hand side is greater than right hand side, so left hand side is factorial n square, and then greater than right side, that means n times multiplied n, that is n to the power n. So clearly factorial n square is greater than n to the power n. We have proved it. So the problem is solved, and I think every one of you have understood clearly. The problem is very easy, but you should remember and learn the mathematical trick, that is the attacking statement or attacking point that is used in this solution, because in the later stage you would see this trick would help you to solve many critical problems. If this solution makes interest in your mind, then my clarification and my solution is meaningful and successful. However, if you want any comment, if you please want to comment, then comment in the comment section. Next we come to another question on factorial numbers. How many zeros are there at the end of the number 100 factorials? So if we find out the number of zeros at the end of the number 100 factorial, we know 100 factorial is 1, 2, 3, 4 up to 100 multiplied. So now we have to find out the number of zeros. So to find out the number of zeros, actually what will we do to know the answer? Actually we may start from a small number. Suppose we have only factorial 7. In case of factorial 7, we want to know the number of zeros. We know factorial 7 is equal to 1 into 2 into 3 into 4 into 5 into 6 into 7. So here we see there are 7 numbers from 1 to 7 and all are multiplied, and we have to find out the number of zeros. Actually for having zeros it requires 5 into 2, and we see that the factorial 7, that is 1 2 3 4 5 6 7 multiplied, equal to 5040. However we see 5 into 2 actually makes 0, and we see that for any numbers, for any factorial numbers, the number of 5 is less than the number of 2. Here 2 is 2 have a 2 and 2 has a 2, and 4 also has 2 into 2, that means 2 2's, and 6 also has 1 2. So from 1 to 7 there are many number of 2's, but there are only 1 5's. So actually the factor 5 is the number of factor 5 is lesser than the number of 2. So here 1 5 makes 1 0, we can say it, and number of factor 5 is very fewer than 2. So the number of factor 5 is responsible for the number of 0. So 100 factorial is 1 into 2 into 3 into 4 into 5 into 6 into 7 into and so on, and the last of into 100. So actually see we have to find out the number of zeros. So here we see 5 into 2 makes 0, and number of factor 5 is very fewer than 2. So number of factor 5 is responsible for number of 0. We can understand it. So to find out the number of factor 5 in the number 100 factorial, we have to find out the number of factor 5 in the number 100 factorial. So here also number of factor 5 in 100, if we want to find out, then we see 100 factorial is 1 to 100, and how many 5's are there. So if we see very minutely, then we can see that in 5 and then 10 and then 15 and then 20 there are the factor 5. Everywhere there are the number 5. So the every different 5 different number there lies one factor 5. So such type of number 5, 15, 5, 10, 15, 20, 25. How many numbers are there from 1 to 100? We have to find out this. So to find out this, actually such number, so every single one time 5 in this type of number, that is 5, 10, 15, 20, 25, 30, 35 and so on. So up to 100 such type of numbers. How many such numbers? Actually 100 by 5, because there are 5 difference between these two consecutive numbers. So the number of such numbers will be equal to 100 by 5 equal to 20. So we see that there such type in the such type of numbers there are only 1 5 for every numbers, and also among these number and also some numbers are there that is 25 and 75 and 50, 75 in this number and 100. So in these numbers there 5 occurs 2 times, the factor 5 in 2 times, because 25 means 5 into 5 and 50 equal to 5 into 10, so 10 means 5, so 5 into 5 into 2. So this type of numbers, that is 25, 50, 75 and 100, there are 5 into 5 cases, that means 2 5s. So 2 times 5 in the numbers 25, 50, 75 and 100, that is 4 such numbers between 1 to 100. So actually logically these numbers, to find these numbers of 2 times 5s in 1 to 100 will be equal to 100 by 25, and more logically, if we want to express to find out these numbers, this will be actually equal to 100 by 5 square, that is equal to 4. So we have found that number of zeros at the end of the number 100 factorial will be 20 plus 4, and actually which is 100 by 5 plus 100 by 5 square, that is 20 plus 4 equal to 24. So this is the answer of the question.
If this class makes any interest in your mind, you subscribe and like my channel. The mathematical tricks that are used in the solution, if you think it will helpful to you, then please subscribe my channel. Thank you all.